I'm sure that you would have solved the previous worksheet that I gave to you, in which we used to use the first formula to find the nth term of an AP. Now, using that formula, I will teach you how to solve certain other sums which are slightly different by using the same formula. In the previous lecture, we found out the nth term of an AP where n was given. Now, in this particular lecture, we are going to learn to find out how many terms are there in AP if the nth term of an AP is given. As for example, in your textbook, on page number 102, you are having example number 4, which goes like this. Which term of the AP, 21, 18, 15 and so on is minus 81? Now what is the difference in this particular question? That number of terms, n is not given. But the last term of the AP, that is nth term of an AP, minus 81 is given. So there is nothing new to do. We are going to use the same formula. Okay. Now, nth term of AP is minus 81. Nth term is represented as an. So for this particular example, the value of an is minus 81. Question says that we need to find which term. So value of n is question mark. We need to find that value. Looking at the AP, our AP starts with 21. So for this particular question, the value of A is 21. And when you take out the common difference 15 minus 18 or 18 minus 21, you will get the value of common difference B as minus 3. So as I said previously, nothing new to do. We are going to use the same formula, that is An is equal to A plus n minus 1 into D. Now let us put the values. Here An is minus 81. The value of A is 21. We need to find the value of n. So this will get n minus 1 remains as the same. And the value of D is minus 3. So first of all, we will take this 21 on the left hand side. So minus 81 minus 21 gives us minus 102. And when I open this bracket, minus 3 into n gives me minus 3n. And minus 3 into minus 1 gives me plus 3. Now if I take minus 3n on this side and minus 102 on this side, minus 3n becomes 3n and 3 plus 102 gives me 105. So in short, 3n is equal to 105. So n is 105 upon 3, that is 35. So we got the solution that 35th term of this particular AP will have value as minus 81. One more important example that we study over here is example 7, which is in your textbook on page number 103. How many two-digit numbers are divisible by 3? Now, how this question is different? In all the previous solved examples, we had some AP, and from that AP we got the values of A, N, and D and solved the sum. But here AP is not given. We have to create our own AP based on the conditions given in the question. So pay attention over here. I need to find out that how many two-digit numbers are divisible by 3. So in short, I want multiples of 3 that are two-digit. So the AP will be 12, 15, 18, and the last two-digit number that is divisible by 3 is 99. Now if I add 3 more, it will become 102, but 102 is not a two-digit number, it's a three-digit number. So the last two-digit number which is divisible by 3 will be 99. Similarly, if I take multiples of 3, so 3 is multiple, 6 is multiple, 9 is multiple, but all these are one-digit number. I want first multiple of 3, which is a two-digit number, so our AP starts with 12. So in short, I want all three-digit numbers which are divisible, two-digit numbers which are divisible by 3. So our AP begins with 12 and ends with 99. Now the same thing that we used to do in the previous sums. Value of A, that is the first digit of our AP is 12. As I want multiples of 3, common difference B will be 3. As you can see that the last term or the nth term of AP is 99. So value of AN is 99. And in the question it is asked how many two-digit numbers. So how many two-digit numbers? So n is question mark. Now after solving this much, the sum becomes very easy. It's just like the sums that we solved previously. We'll use the same formula for the nth term, that is an is equal to a plus n minus 1 into d. Putting the values, the value of an is 99. The value of a, that is the first term of a, is 12 plus n minus 1 into common difference is 3. So when I take 12 on left hand side and subtract it from 99, I get 87 is equal to, opening the bracket, 3 into n, that is 3n minus 3 ones are 3. Now when I take minus 3 on the left hand side, 87 plus 3, 90 is equal to 3n. That gives me n is equal to 90 upon 3, that is 30. So in short, the answer of this particular question is that there are total 30 two-digit numbers that are exactly divisible by 3. So I will send you certain more numericals which are based on the two examples that we just saw, and then in the next lecture we will start exercise 5.2.